All computers, phones and tablets knows which DNS server to use. These can be configured manually, but most devices receive the information along with its IP address from the DHCP server. Generally, a device is configured with 2 DNS servers. The purpose of multiple DNS servers is for redundancy. The second DNS server is only used when there is no response from the first one. The DNS server used by a client does all DNS lookups on behalf of the client, which we will have a look at in this lecture. The lookup process is also called resolving, and this DNS server is called a local resolver. It's recommended that the local resolver is placed as close to the client as possible. In some environments, the local resolver is either the broadband router or a DNS server operated by the local ISP. In corporate environments, the local resolver can be an Active Directory server placed on internal LAN. The important thing to remember here is that normally the client only talks DNS with the local resolver. In some environments and operating systems, the local resolver can be run on the client computer, but this is relatively rare, and for the purpose of this lecture we think about the local resolver as a server placed somewhere near the client. Let's say that the user wants to visit the Google web server. The client computer knows about the hostname because the user has entered the URL www.google.com in the address field. But the client computer needs to know the IP address to send HTTP packets to the web server. So our client sends a DNS query to the local resolver asking for a record of www.google.com. The local resolver is not authoritative for the domain and does not have www.google.com in its DNS cache. If that information has been in the cache, it would just send a DNS reply back to the client with the information. But for this example, we assume that the local resolver cache is empty. There's only one thing that the local resolver always knows, the IP address of the root name servers. That information is called the root stub, and is statically configured information stored local on the resolver. So our local resolver sends a DNS query to the root name server asking for an A record of www.google.com. The root name server is not authoritative for the domain and does not have this information. But there's one thing that the root server always knows, the IP address of the authoritative DNS servers for each top-level domain. That's the sole purpose of the root name servers, to be able to tell the world where to find information about each TLD, top-level domain. So it sends back in response telling our local resolver that it does not have the information about www.google.com, but that the DNS server for the .com TLD can be found at a specific IP address. This response is called a referral response. Our local resolver gets the referral response, which contains the IP address for the .com name server. It sends the request for www.google.com to that server. The server does not have the information requested, but since it is authoritative DNS for the .com top domain, it has delegated the ownership of the google.com domain to Google. It sends back a referral response to our local resolver, redirecting the query to the name server that is authoritative for the google.com domain. The resolver sends a third request for an A record of www.google.com, this time to the google.com name server. Bingo! This server has the information requested. It looks into the zone file of the google.com domain and finds an A record with the name www. The IP address is 1.2.3.4, and the server sends a reply back with that information. Our local resolver receives the information and sends a response back to our client, answering the received question. Our client learns the IP address for www.google.com and can start talking HTTP with the Google web server. If the client needs to contact Google's web server again a few minutes later, it has the information cached locally and does not have to ask the local resolver again. Also, if another client asks for an A record of www.google.com, the local resolver has cached that information and can send the answer back to the client without going through all the work with looking up the hostname again. To conclude this, normally a client only talks to the local resolver. The local resolver does all the hard work of resolving DNS queries. It starts from the root and goes iterative down one level at a time in the domain hierarchy until it finds the requested information. All this happens invisible for the client, who only sends queries to its resolver and gets answers.